Hello, welcome to Rubber Duck Engineering, episode number 112. Tonight we're going to do car and cutter?
Cutter.
What?
Car and cutter.
Car and cutter? Anyhow, some part of Lisp. Hi, Dr. Barth.
Hey, Eric. How are you?
I am excellent, actually. It's been a really good week. Very calm. So,
I like how you aggressively pick the wrong pronunciation. When Eric made the thumbnail for the episode, he called it can and cutter.
I really I did a little bit of Lisp for 2 hours one day, probably after reading a Paul Graham book about 20 years ago. And that is my experience with Lisp until last week. So
yeah, these are pretty obscure names. When I actually learned Lisp, I learned them as head and tail, which is way more understandable because you could probably tell which one is head and which one is tail. But which one is car and which one is cutter, we'll figure it out.
So I looked up on Wikipedia today what they were, and there is actually a pronunciation. I don't know that I'm doing it right, but I did play the little audio, and it's the something device register? No, current.
Yeah, it's from some super old computer where this was like they stored the cell that we did last episode in some like architectural specific thing, and then there were registers for the two halves.
I'm certain there are. I'm just absolutely ignorant of this side.
Oh, William is an actual Lisp hacker. Yes. We'll get there. We might do cons even. Cons is the opposite of car and cutter. All right. Should we go to the code machine? Oh, I think Eric is slightly distracted. So before we do car and cutter, we're also going to have to do quote. Because right now, where we left off last episode, we're doing a read eval print loop. And we had read and print, but no eval. And so that's great. But once we start evaling things, we need a way to not eval sub-expressions. So the way to do that in Lisp is with a quote. So I did a few things in the Easy Bake Oven between episodes. Last episode, when we were tokenizing the program, we just split it on spaces. So we had to adjust all of our test cases to have a space between the parentheses and not the parentheses. And what I did is I actually put a real tokenizer in place that knows how to actually tokenize parentheses and symbols and stuff. And then I just made the parser work with that. I also split things out into files, so everything wasn't in the main file. Yeah, so if you see here, there's a token class that specifies the different tokens. So there's open paren and close paren, they're just the parenthesis token. And then symbol is if there's like a string, like a A or a B or whatever. Print hello there. Yeah, we can make a print function too, but we have to actually make strings instead of symbols, which is sort of tricky. So I think the first thing we need to do is we need to add the quote operator. So the quote operator is going to be a new token called quote. And then we're going to figure out have to lex that. So if, I can't control Eric's screen, but if Eric scrolls down to around line 40, then we can do this. Eric, you're muted.
Sorry, that was the problem. I realized I was muted even though I was trying to talk to you.
Okay.
I must have clicked the wrong button. Okay, here we go. I'm back. I would love for a little bit. I know you mentioned to folks that you had done some stuff in the Easy Bake Oven. Can you walk me through? You made a real tokenizer, it looks like.
I made a real tokenizer. Okay, I can take the quote out. So that was the thing I just added.
Okay.
Yeah, the tokenizer is just a very simple class that takes an input string. It keeps track of where it is in the string and then can buffer some data as it's going. And then next is a function that just returns the next token out of the parser. So it does very simple. It just walks through the input string. And like if it sees a left parenthesis, then it emits a parenthesis token. Right parenthesis, it emits a closed parenthesis. And if it sees white space, then it splits up the symbols. And so as it goes, if it sees anything else, it buffers that in the symbol. And then basically if it sees a left parenthesis, if it has a buffered symbol, it backs up and then emits the buffered symbol. And then we come in the next time, we'll come back here and return the open parenthesis.
I don't see any tests for your tokenizer.
The tests are all up in mod.rs.
Okay.
So I added all of the, I added versions of all the tests that didn't have the extra white space in them. And then I added all of the tests that we had talked about in comments as well.
Okay, so we have a parse test, parse input unwrap. Yeah. Just sort of trying to get my brain up to speed here. And then we value, I see, this comes back as a cell. This is not just your tokenizer, this is the full parser here.
Correct. Yeah, this comes back as a cell whose head is A and whose tail is nil or none.
Okay.
And this one down here does something similar. And then we can parse the empty left paren, right paren, and that parses as nil. Which is, I checked at another like random Lisp interpreter, and that's what it did too. And if you just have A and B with no parentheses, that's a parse error. And then I tested the serializer as well, which serializes all these cases.
I believe you. Okay, so tonight you said that we are augmenting your tokenizer and parser in order to handle quote, which is until you hit the next. Go ahead, sorry.
Yeah, so right now we don't eval, we just read in and print. But when we add an eval step, the quote will basically stop the evaluation. It'll say, instead of evaluating this sub-expression, just give it to me as data.
Okay. So if we cargo run, we're going to get into our REPL here. We do A, B, or something like that.
So the correct output is this should be an error, because it should try to basically call the function A, which doesn't exist. But instead, if you did single quote, left paren, then
that's going to be a parse error because we don't know what single quote is.
It's currently a parse error, but what it should be is it should return just what AB is without being evaluated.
See, so this one should print this?
Correct. So
you sort of lose the quote in it?
Yeah, the evaluation like strips away one level of quoting, but then gives you that data as a tree.
Makes sense.
Yep.
Okay. And this is all a prereq to be able to do like CAR
so
1 or whatever.
So what I would try to do is say CAR of quote A, B, quote left paren, A space B.
Okay.
So with that should return A.
Really, our print is not aware of quote, but yes.
Correct. Okay. Well, right now we just treat quote as any other symbol character. So it's if you replaced the quote with X, it would have done the same thing.
That brings up another set of test cases. Do we need to test what are valid symbol characters?
We could. Right now we just accept anything that's not white space as symbol characters. I'm sure there's actual like legit, like these are the proper symbol characters for Lisp. I just don't know what they are.
Okay, fix me test which are valid symbol. So we were going back to before I got distracted and came up to speed. We're adding quote support into tokenizer.
Yep. So we have a new kind of token, which is a quote mark.
Okay.
And then we need to tokenize it, which is very easy. We just add it here to our match statement. Okay. Copilot did it for me.
Yep. Chase you here. Okay.
But now the more tricky thing is we need to add it to our parser.
All right, one second, sorry.
Yep. So the reason this is a little tricky is right now our parse representation just contains these cells. So we're going to have to add a new kind of value, which is a quoted value. So I'm not sure exactly how to do this, but we'll figure it out. So we start with quote mark. And
was that Copilot or?
This was Copilot. It's totally wrong, but
okay.
It's wrong in an interesting way. All right, this is wrong. But the we don't know what
down the parser. Okay.
We don't quite know what to write here yet. Which is so we need a like quoted value,
which just takes a value.
We need to somehow save value, like the quoted value, but then we need to like keep parsing somehow. I'm not sure exactly what to put here.
Does it just recurse?
it recurses, although we've written a non-recursive parser.
Mm-hmm.
Instead, we have the stack here.
So is it just a like a quote stack?
I think what's happening is the things that we have on the stack are not like rich enough. We need like a fancier data structure here.
So do you keep track of parentheses?
Whenever you see a close parenthesis, you pop the stack.
I see. And what is it we keep on the stack? The current like open value or whatever?
Yeah. So the thing that's on the stack is when you're like when you have A, B, C, D, all those values that are between the parentheses. That's what the current value of the stack is that vector of things. But somehow when we pop the stack here, we need to somehow remember whether, like, you can also quote a symbol, by the way. So like this is a valid input. It's like, print
Quote 1 or whatever?
No. Yeah. Like the thing inside of quotes is going to be any kind of value.
Whoa. Why do you have spaces? Say you had a string. Do strings exist? Are those double quotes?
String is a different kind of data type than quoted things. Because a string is literally the string, but the quote actually gives you the whole syntax tree.
Okay, so
I would jump over to values here to sort of start. If,
are we making a parse tree?
Are we making a parse tree? Yes, the parser is supposed to return a parse tree.
And what does it do today?
It returns a value. Like a value and a parse tree are the same thing. This is actually the cool thing about Lisp, is that in Lisp the parse tree and the values are the same. So you can.
I see. So quoted is just another kind of value, is what you're saying.
Correct.
Okay, that makes sense. But the question is, you're saying we need to somehow. Sorry, I'm clearly. I was a little distracted. I'm trying to bring my brain up to speed. The stack that we have is values. So what's wrong with just pushing a quote onto the stack? What if we save value quoted? Like this. Let's see, what is this? Sorry, this is. Oh, I see, because the stack is a list of values.
Yeah, so here when I pushed like this, I somehow needed to say when I need to push something. Right? I need to say stack.push.
Well, what if you just abuse what if we just push a quoted value, and then as part of close paren, if the first thing is a quoted, we shove them all inside that. That's kind of like, you might as well honestly change your data type.
I think we need to change the data type. So I think we need to have like an enum here. It's like the things that are on the stack. Like enum.
These are like parse values or whatever.
Yeah.
We had something like this in the HTML parser.
It's like parse. It's like tree builder state, right? Like parser state. There's like quote and there's like list, right?
Okay.
And list has a vec of option value, right?
And doesn't quote as well? Is this just a bool that's like is quote?
Well, we can have multiple quotes, right? You can have like quote, 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 quote.
Oh.
Yeah. So I think what I want to do here.
So quote
and then I have
has a parser state as its. This would be a box parser state, but yeah.
Box parser state.
I'm not saying you should accept this. I'm trying to like argue with you here.
That's fascinating. I wasn't. Can we try it without this, and come back to this? I think I have an idea how to do this.
Okay.
So I have a top now, which is like a option not do about that. Okay, so let's start. Let's push onto the stack. Parser state list. Okay.
Okay.
So now here I want to push parser state quote. And then here, when I pop off the stack, I want to say, I want to match the stack.top. And I want to say, like, if it's a quote, let's unwrap it. Yeah, if it's a quote, I want to make a quote value. I feel like I'm not articulating.
It's fine.
You see what I'm saying here? So like on the way up, I pop the stack because I hit close parentheses. And then I go compute my value from that. And then if this top of the stack is a quote, then I pop that off and I wrap it in a quote. Otherwise, I just.
So isn't a quote. So, okay, we understand what the tokenizer is supposed to do. And we understand what the end parse tree is supposed to look like, right?
Yep.
What we're debating is how to handle the internals of the parse state as we're parsing.
Right.
And currently, our internals of the parse state are really kind of sort of weirdly dumb in that they just keep an open list of. We sort of like assume that we're in a set of parentheses, and we keep the list of values inside that.
Yeah.
And we now need to somehow keep our marker state, because all quotes are is they're just markers in the tree. They're like barriers in the tree. They're like eval barriers that you consume while you're evaling. Your eval will go up to a quote marker and will consume it, but then just return whatever's beyond it. And so we need to somehow have similar sort of markers in our parse tree.
I feel like we need like maybe we need like an AST. Would that help us? Like, what if we had a syntax tree?
That's where we were going with this, and that's where I was thinking that the quote.
Right. So then it makes sense for quote. So this is like a abstract syntax tree.
This is a syntax node.
Node, right? Syntax node. Okay. And now I see where you're going. Okay. So this is a syntax node. Then it makes sense that it's a quote as a syntax node.
So yeah, go ahead.
And this is a vec of syntax nodes. And then there's symbol, which is a string.
Okay. So another way we could cheat. So this, I think, would totally work. We could continue down our previous cheat by just having quotes be literal markers that just sit in our list. And when we hit one, we slurp up the whole rest of the list and shove it inside the quote in the thing that we return.
Okay.
Right. It's just like this the save value on close paren just becomes, hey, check the first thing. If it's a quote, okay, slurp up everything other than the first and shove it in a quote. Otherwise,
I feel
I'm
like
not sure how it would work. But go ahead.
Yeah, I think the syntax node approach should work, right? Like, I'm just a little bit unclear, like when we want to initialize this, we want to make a root. Okay, how does this go? Let mutt.
Why do you need a root? Why is the root just a list? Oh, I see.
See, the problem with this is when I construct the root, I don't know what to put here yet. So I think it's maybe these are all options because I haven't filled them in yet.
I see. The root is just option syntax node. No. Like, well, I mean, yes, that. The question, like, are we building up the tree from the leaves backwards such that these are immutable and always have things, or not?
That's a good question. I think that's the sort of central question that we're wrestling with here.
What order? Because like, there's one way to build a tree, which is where you build from the root and you just allocate a root, but it has to be mutable because you then want to add things to it. Or there's a way that you build a tree where you do depth first and you build from the leaves backwards, but then you can have an immutable tree.
I bet we're supposed to build from the leaves backwards. Like that feels more Lispy to me.
Okay.
I'm not exactly like I know we could do it recursively. Maybe we should try to do it recursively.
Well, so one of the things that I have difficulty with engaging with this problem is I don't know if there are other magical stuff in Lisp, or is this it? Is like quote the only magic?
Quote is the only magic.
Okay.
There's some more magic on the eval side, but this is the last thing we're gonna have to do to the parser.
So there must be some implementation that just hits a close paren and then just starts backing up until it sees a quote, or it sees an open paren and then it looks to see if there's a quote right before that open paren.
Yeah.
I don't know.
Let's try a recursive version.
Okay.
Parse value. So we're going to take in a mutt tokenizer.
Did we miss our comment stream? I apologize that my brain's only been going about half. Let's see. I think William said you need to know when to pop it. Sorry, we lost context on that. V8 says, what do CAR and CDR mean? I think we tried to explain that. There's some archaic reference to some specific piece of hardware.
William explains it. If you keep going, he's got a good explanation.
Oh, okay. And then William says the output is just a quote few of the part tree. Okay. CAR and CDR are the first and second elements of a pair. Yes. If you look them up on Wikipedia, they reference something, the current address register and the current device register or something like that. But yes, they're head and tail. And yes, CDR of quoted A, B. Whoa. So quotes are like transitive?
Well, it's just saying that it evaluates the symbol B, which you could express as quote B. Like it evaluates to an unevaluated thing called B, the symbol B.
What would that, if you didn't have the quote there, what would that show? Would that just be invalid? Because trying to take A of B is, if A is not a function, is going to go black.
Later on, we'll have like functions that have arguments, so we'll have variables. And so if you just wrote B without the quote, that would mean the value of the variable B. Whereas the quoted version means the symbol B that you could then look up to get its value if you wanted to.
Sorry, I meant CDR. If we take Williams' expression, we say CDR without the quote marker in there, AB. Yep. I presume unless A happens to be a function, a urinary function, this is an error. That would be an error.
It would be a runtime error. You get the error A is not a function, or unknown variable A.
You keep referencing these functions. Are those also going to be magic, or is function just another literal?
I mean the CAR function?
No. Clearly you can define a function in Lisp somehow.
Yeah, so there's a special function called lambda, which is just a function like it is a little special on the evaluation side because it normally with a function when we get to evaluation you'll see this.
But it just parses as a symbol. Lambda is just a reserved keyword symbol.
It's not even reserved. It's just a built-in. There's like a built-in function in your default environment.
Okay, sounds good. All right, so you said you're trying to take us to recursive land, which my gut says is not necessary, but let's try it because it's probably simple.
So I just want to return. So if I got a symbol, that's easy. I just return some symbol.
Okay.
So if I got a quote mark, that's easy. Then I want to just I want a parts value, my tokenizer. I want to return some value, quote.
Mm-hmm.
So that's easy. Man, more parentheses. Insert more parentheses. Now we just need to do open parenthesis. We need to create a vector. Values equals a new vector. Then we need to say, Copilot suggested something totally crazy, but we'll forget about that. We basically need to call parse value recursively. And at this thing, we need to return none, basically.
I see. We have a stateful tokenizer here. We're not passing around the token stream or anything. Or the tokenizer has like a token stream.
We don't have quite the right contract here, but we're getting there. So we need to say while let value, while let some value equals this.
Oh, I see.
Values push.
Okay. Yeah.
And once that's done, we'll return, okay, some value.
Yep. From list or whatever. Yep. From vec, I think you called it.
Oh, I think it's cell.
Oh, what's the difference between cell and a value again?
Cell is one kind of value. Like a symbol is a different kind of value.
I see.
Now a quote is another kind of value. So this is fine, except if let's see. Maybe this is okay.
Okay, so what happens if...
This doesn't quite seem right, because it seems like this case, like none is a valid value. We need like another kind of marker for like, I'm done. It seems like this could just be an error, which is like or like a...
So how two closed parens in a row, or an extra closed paren, how's that going to fail out here?
Right. So here, we'll just see whether the tokenizer is, like when we're done with parsing everything, let result, let root value equals, try parsing the values, and we need to like check, we're going to return okay value, but here we need to like check that the tokenizer is empty, right?
Well, I'm sorry, why is this not just our previous thing where like open paren pushed a new thing to the stack?
What we did is we're using the runtime stack as our stack, so that on the way up, it's easy for us to quote things we want to quote.
Yeah, that all makes sense. Okay, so open paren. But like another way to do this would be option.
This is not while, actually. While is incorrect here. This is like if.
Option vec. Whoa. Did I break something? Oh, I'm following you, that's why. You're off doing something else.
Oh, sorry.
That's all fine.
Can we try running the tests?
Yeah.
We have two errors. Oh, there's no...
Missing match arms. Some quoted, not covered.
Oh, okay. Yeah, we need to obviously handle that case. Value, quoted, value, quote mark, and then we need to print the rest of the value.
Okay. Let's try cargo test. They're sad. The pandas are sad. Okay, what do we got here? Mismatched types.
Well, why didn't the analyzer find that problem?
It could be the analyzers behind.
That's super weird.
Well, let's just try cargo build and see. Oh, what did I? Cargo, not building. So the analyzer, how do we kill the Rust analyzer here? Server. Like this could all be from like when I used Rust a year ago, I had to like opt into the new Rust analyzer, which wasn't yet stable. Even the old one's deprecated. So it's possible like my Visual Studio Code is funky in some way, which is confusing Rust. Why does it still?
Okay,
Looking at the wrong.
Can we try just investigating one of these errors that it's giving us and seeing whether we think that the error is actually a real error?
Mismatch types. In parser 87.
Mm-hmm. Parser 87. Yeah, that's totally wrong. Like this code is close but not correct, right? Like, oh, we have to do that.
I just don't know.
I don't know why the analyzer isn't finding it.
Well, like it's very possible that reload required. Okay. Like it's possible that I may have a funky because I was on a nightly build and I had to have like I changed my analyzer. I had a funky setup a year ago. I expect the default setup is now the correct one, but my configurations may be confusing the default setup. Let's see if it finds it this time. It wanted to restart for whatever reason.
So I lost the live share link.
Oh, sorry. I can
fix that.
I can get you. 1 second.
Don't want to link the live share link over the live stream, or somebody else is going to come into your editor and start editing things.
No, we're still sad about life.
Okay, we can just fix the errors from the command line. I feel like trying to debug why the analyzer isn't working is going to...
I agree, but oh man, what did it do? It picked some other random project. Okay. If I instead, if we take for 2 seconds and we look at preferences, right, and then we look at Rust. Let's just make sure I don't have anything. There's a way to like show me the like YAML file of this. Do you remember?
No.
Well, we may have to give up. Fine. We'll just use the command line this time. I'll fix my Rust setup after. Okay. Cargo build. It worked last week. What? Okay. Some errors. Yeah, fine. No variant associated with item quote. Okay, parser 89. Value doesn't have a quote. It says quoted.
Oh, quoted. All right, fair enough.
This is really gonna slow us down. Okay. Parser 89, because it won't even jump to definition for some reason. I may just have to restart my Visual Studio Code or something.
You have to do box new there as well.
Okay.
You're going to do box new there as well. You want to try restarting Visual Studio?
Yeah, I
VS Code?
think I got to try restarting Visual Studio Code.
All right.
I don't think we can fly completely analyzer blind here.
It's so funny because I used to write code without an analyzer all the time, and I think writing Dart code is really what sold me on the analyzer, because the analyzer always just gives you the information like right in context, and you can just like fix it and like hammer through it and like get to the end. But trying to go back and forth in the command line is super painful. I agree.
Well, particularly when links weren't working. So it's loading. I'll add us in there in a second. Or I guess you can all watch. See what the Rust analyzer is doing.
It was finding a bunch of problems.
Is it?
I mean, it found like some of the problems, but then it sort of gave up and stopped.
I don't really know how to like settings. If I could see I want to see which settings I've changed. Right, there must be a way to like. There we go. Filter to modified. Okay, edit settings. Okay, so nothing's changed there.
Mm-hmm.
All right, let's look at user. Filter to modified. Okay, there's a lot more. And we have Dart, extensions, Copilot, Notebook, Window, Workbench. I don't see anything relating to Rust. Okay, and then we could check our Rust up. I mean, this is gonna devolve very quickly. Rust up. Okay. Is there like a Rust up doctor? Like, what do you think?
I think we just work through them on the command line. I don't think we've done a bunch of things to try to make the analyzer come back online, and it hasn't worked.
Cargo build. Okay. Well, we'll do what we can. Sell from Vec. Value found option.
So it's supposed to take just a vec of. From vec is supposed to take a vec of option values. And what are we actually giving it?
Expected enum value. Got option. I think this sum is extra. Parser 84. Let's see if this. No, see, it's not even linking to the correct place for some reason. Okay. 84. Rust option value. What's from vec? Oh, I see. It takes a vec of option values. Okay.
Right. So we're supposed to. You see where it says let sum? While let sum, just you take away the sum there. Yeah, this is the problem. Yep. Okay.
Nope.
This highlights the problem we were discussing, where our termination condition is not actually correct, but we'll have to come back to that.
Okay. Could not compile.
Can you clear between things? I'm worried that we're seeing older errors.
Does PowerShell have a clear? I don't think PowerShell has a clear.
There's a trash can. I don't know what the trash can is.
To delete the PowerShell terminal. we went from spaceships and lasers
to digging rocks out of the ground with our bare hands.
Yeah.
Okay. The good news is we're down to one error, so we got that going for us.
I think our chances of getting to Cutter today
They're fading fast.
Okay.
Expected enum values found option. Okay, yep. So we need to get rid of that sum. That makes sense.
84.
84. Yeah. We got so excited about sums. Okay. Yeah,
irrefutable while let pattern.
correct. Now this is showing us a real problem. So when close paren, if you give me the link again, I can have an idea for how to solve this.
Lost the link.
Yeah, we need to return a sentinel from this function.
I clicked to like mail you. Does that like make it appear for you? It may.
Oh, no.
Make it stop. Okay. Hold on to your hats here, folks.
This is a professional show.
Technical difficulties.
Technical difficulties. We were doing so well. We were going on a roll for like many episodes before having
Did you get it?
I did. Thank you.
Okay, second. We need the little
the we're doing it live. Oh, you made a technical difficulties banner. Perfect.
Well, we need the screen when we were when I was a kid. The TV screen would every once in a while go to the color
the dancing bears. Yeah.
Oh no, it's just go beep or whatever. Remember that was like the test of the emergency broadcast system.
The like color
tornadoes. Go ahead.
Yes.
Anyways, I grew up where there were tornadoes, and the sirens would run at least once a month at like noon on a Wednesday or whatever, in case the tornadoes were coming for us. So tell me why I'm wrong here. I was starting with that open paren could just create the maybe values, and then close paren could check to see if it exists and otherwise slurp it up. I see. Symbol would then push to the open values.
Yeah. Well, then the question is, how would you recurse?
How would you what?
How you could do it that way, but it would. You could peek. Yeah. Okay. You want to do it that way? We can do it that way.
That was where my brain was going.
Right. So to do that, we need to. So this will return error because this is like an unexpected one of these. So to do this, we need to return. Our tokenizer needs to have a peek function.
Why? Okay. I think you're a step ahead of me, but go for it. That's fine. Why does this need to return an error? This would check to see. That's why this is option. If the option vec doesn't exist, close paren returns error. Otherwise, it slips them up and returns them. Why do you need this loop? I see. I would have moved the loop out. I feel like we're lacking a coherent design here, and that's why we're sort of fighting each other. Right? We previously had this loop outside the match.
Mm-hmm. The reason you can't do that is because when you want to call parse value recursively, you need to pass in a tokenizer in a good state, like in a coherent state. So peek allows you to look ahead.
Yeah.
Yeah.
I hear you. You have the mutability problem of that if you are looping on the Okay.
So let's just make it simpler. Like next is close paren.
Mm-hmm. I remember we had paren.
It'll be easier than a general purpose peek.
Yep.
Let's put that on our tokenizer.
Mm-hmm. I can chase you.
Mm-hmm. So this isn't quite right. This is close to right. No, because
you need to be able to skip white space, don't you?
Correct. So we need like a skip white space function.
I see. So our peek actually like modifies us.
Yeah, like this is not. We're getting a little messy here. Use white space. something like that.
Yeah, I wonder if we just aren't thinking clearly and need to do this in the easy bake oven.
Yeah, probably. Like, let's write a to do about this. Like, to do, like, it's gross that this modifies the parser state. I think more. We need to think more about how to terminate a list parser. I think it's also not going to be correct in the end case. Oh, no, that'll be okay. Yep. Okay, does that build? This is rubber duck engineering, not titanium swan engineering. Technical difficulties are expected in place of 5 nines or 11s. Thank you.
Does that build? Since we don't have an analyzer, we got to go. Titanium swan, what?
This person just gets the vibe of the show, and I really appreciate that. You're exactly right.
Okay.
Oh, skip white spaces. I'm supposed to call like that. We're snake case people.
Or snakes.
Oh, this should be in snake case too.
More snakes.
More snakes.
Our call site here is. Oh, there we go. We built.
We built. To the test run?
I suspect the crash or fail. Oh, 3 failed. Previously, they crashed in a... Oh, panicked.
Okay.
Does this follow? Oh, hey, it did. Grateful for small favors. On an error value, parse error. Interesting. Okay. So let's walk through here. Parse value. We get our token. Yep.
Can we just walk through it in the can we walk through it in the debugger?
Sure. Easily done. Well, the question is, we might want to do it from...
I think you should go to the actual test that has a debug button on it.
Well, I agree with that. The question is... Okay, so maybe we'll comment out this one.
Sure.
Bug that.
All right, you need to put the A symbol back, I think.
Okay.
Hey, can you remove this banner that's flying by the screen? It's super.
Oh, sorry. Yeah.
We are still experiencing technical difficulties. It's true, but it's a little distracting.
Yeah. Sorry, I added it and then forgot it. There we go. Because I can't actually see the stream while we're in the code machine. Because that's the level of tech that we have here on what was it? Iron Swan, Titanium Swan Engineering.
This is rubber duck engineering, not Titanium Swan engineering.
Okay. All right. So let's. All right. So what do we got? Our current token is an open paren. Makes sense.
Okay.
We're not a closed paren.
We parsed again.
What?
That's good.
This is going to get. This is going to end up wrong.
What?
Because we're never going to consume the closed paren.
Whenever. Oh, that's a good point. That's probably the bug.
It's like it's what is our current token?
But we don't want to consume the current token. We'll concern down here. Assert next is some token close paren.
Okay.
I never know whether
it starts run or not.
Yeah, whether it starts to run the thing or not.
In Rust,
they do, but I never.
Well, you spent years with the whole way that we ran debug-only code in Dart was throw it inside an assert.
Yes, these are like epic asserts that just like printed random values. And
if you look at the Flutter code, there's just pages and pages and pages of code that is all wrapped inside an assert.
Because there's I guess in Dart, the asserts aren't run in production. And there's no other mechanism for like, this code is only for non-production. So we just abuse the cert like nobody's business.
Abuse?
Used effectively.
True. Okay. Run and debug. Oh, we're just going to test to see the thingies. For a test. Assert token.
Oh, I need assert EQ. There you go.
Rookie mistake. What we got? Of course, we got to add partial EQ to our token. Token needs, what is this? Okay. It's like derive.
Debug, yeah. Partial EQ, regular EQ. Sure.
Okay.
Oh, great. Success. So somehow, success. Can we make a commit? Can we commit this? Because I think the chance that we break this immediately is very high.
How do I begin here? Okay. This is unnecessary. Okay. And so,
that's also those bottom two are wrong. Yeah. Anyway, you can just get rid of those.
This we can just. Oh well, we need to fix it in mod. Are you doing that or me?
No, go for it.
Okay. This is why you always look at your commit before you just go blindly do it. Your own little mini code review. Okay. Parser, that looks reasonable. I see. So this is add. This is refactor the parser for quote support is what we're doing here.
Correct.
Refactor parser in prep for quote support. RDE number 112, I think we're at.
Something like that. Okay, so now the whole thing we're trying to do is add eval.
Add eval?
Yeah. So I think we make a new file called eval.
Is eval going to do anything?
Yeah, eval is going to be amazing.
Like, don't we have to do like symbol lookup or like?
Yeah. But we'll start with very simple. That's the joy of it all. Eval.
Okay.
Value. We decide as an option value.
Really?
And this returns an option value.
Have to be like is none.
At some point we're going to need
eval none.
That's fine. What does nil evaluate to?
I see.
I think a nil just evaluates to nil actually.
I see. This is the conflating that I encouraged us to do between. We sort of repurpose null pointer or whatever to be okay. All right, it's fine.
So I'm not sure exactly what we should do here, but we should match. So if match value, else none. I'm not sure using option was better than just making nil a thing.
Yeah, I agree.
What are the case?
Yeah. I may have sent us down the wrong path. The reason why is that it's confusing here that a normal Rust viewer would think of that none as being null, and it's not.
Yeah, that's okay. So what are our values? We need to import values. Use values.
Okay.
So what are our value types again? Cell, symbol, and this.
Mm-hmm. Oh, that's right, because the analyzer isn't here to fill them in for you.
So I don't know if that's right. That's what Copilot thinks the answer is.
Oh,
So this is really result, right? Because we can return an error.
Mm-hmm. Yep.
So let's return unknown symbol. Eval error, quote, unknown symbol.
Okay.
Later on, we'll have to bind symbols.
Yep.
And then this just returns okay value. That's the magic of quote.
Okay.
Right? And then cell, we don't know how to evaluate yet. Let's return another error eval, but we'll get there soon. Eval.
This is just unimplemented error.
It's unimplemented, yeah.
Doesn't Rust have an unimplemented error? But I guess that's not an error type.
Probably. Let's add eval error to our error collection.
Why do we not have to give the type? Did we redefine result to have our default E?
No, I just think that it hasn't complained yet.
I see. Because I know we did that in a different usage of Rust. It's all coming back to me. Did we decide that was Celine Dion last week? Or was that a different song I was quoting?
We should add this to our read eval print loop.
Which?
The eval.
Oh, totally. We also have to make it compile first, but yes. Oh, cargo test, cargo build. Okay. You don't have symbol.
This is values, cell and symbol. Like that.
We're down to a previous error. Okay. Expected option found struct box.
Okay, this is okay sum.
But then you got to shove it back into a value.
Oh, that's not right. Quoted. But you can quote. Why can't you quote nil?
Well, we could also do this would be inner. Whoa, I chased you.
No, it's a box. We need to unbox it. We need to unbox it.
Oh, I see.
R.
Okay. That makes sense. Okay. Isn't there a way to like unbox during the?
Oh yeah, we could say like box.
Yeah.
That's probably better.
Okay.
Yay, sparkles. A little delayed. Sorry. Oh, apparently you can't do that. It's mad at you about that.
Well, that just looked like the wrong syntax. But go ahead.
How do you get something out of a box? I forget. Take. I don't know. Let's take.
That borrow is mutable.
Into raw.
We want to like consume the value as part of this sum.
Does not consume the value? Do we not?
Oh, into raw is not what you want.
No. Into inner. Take this box and destroy it.
No method into inner. All right.
On box? Oh, nightly only. How do I get something out of a box? Take it out of the box.
Must.
Unbox it. Give it to me.
Do you reference the value?
With a star? So the star was correct? Okay.
Yeah, it seems reasonable. I mean, boxes are pointers, effectively, right? So. Oh, help if this is intentional. Eval error is never constructed.
Yeah,
Okay.
because eval is not used. That's fine. Well, we should use it. So in main here,
Could not compile. Generated 3 warnings. Okay. Eval is never used. Eval error is never constructed. And then unused variable cell in eval. But that's fine. We just never call eval. All right, so you're saying that we need to change our main, which you just did.
Mm-hmm.
Okay. Okay. Is it really called VM? I think we don't expose it in the
VM eval.
mod VM. Oh, is eval not in mod VM?
Oh, I didn't
mod
make it
VM at the top.
I didn't make it pub. Yeah.
Oh, hey, we have problems back again. What?
That's great. That's fantastic.
Great. I don't know what changed.
I agree that we did not use cell. That is an accurate complaint.
Why did you come back?
I don't know. Maybe it woke up from its slumber.
What?
So we should try it now. We should see if quote works. We should be able to this should have changed the behavior in an interesting way.
This is why people think computers are magic.
They are magic. So now if you say left paren a, like a space b right paren, we should get an error. Unimplemented. Great. So we'll try this a. We should get symbol. Oh, that was a parser.
It wants the other quote.
Hey, we did quote. We haven't done CAR and CDR.
We could.
We could. Do you want to
we
do it?
We do the most basic one. We could just hack it in, right? Like that's like a minute, right?
Yeah.
We just hack it in. We don't do any. We just where is it? Eval. Right here.
So we need like our built-ins. So we need to write.
Oh, okay. You're doing it fancy. I was just.
I'm just going to say the CAR function.
Yeah.
Is going to take
an option value.
A value, which is an option value.
Mm-hmm. Which we need to fix, but yeah.
Yeah. If
let's return. Is it head versus? It's head versus tail. I see. It's either going to return the first or the last.
Match value. If it's a sum pair, if it's some. Apparently, we're supposed to say pair instead of cell, but that's fine. Cell. And it's going to return.
Cells have multiple, not pairs.
We can return cell dot. What is it? What do we call
values at first or something?
I forget what we call it.
Box cell
left.
Oh, it is just left and right. Oh, okay.
Left. Yeah. Otherwise, we're going to return. This needs to return a result option value.
Yeah, this is okay.
Error.
And this is, I think, just this.
Mm-hmm.
And Copilot added a few too many.
Error.
I'm just typing in CDR while you go. Why did it collapse? Okay.
Now we need to do the cell.
It's sad about. Okay.
So match cell left. Get some symbol.
Mm-hmm.
Function name. Then we do something interesting. Otherwise, we do our eval error.
We just need to do our built-ins. It's like a list. I have no idea how to do a.
That's map.
It's I don't know what a function type is in Lisp, and not Lisp, Rust. That has left my brain.
That's okay. We'll just hard code it for now.
Yeah, exactly.
If the function name is car,
Mhm.
then do that.
Yep.
Cutter, else return eval error.
It's just cell, not cell.write.
No, it's cell .write. Because
You're right.
we've consumed
You're
it.
right.
Yeah.
Okay.
Unknown function. We're gonna have to make this fancier, of course, but this will
Yeah, of course. But for
start it.
our overtime,
Yeah.
all right. Yeah. Oh, it's so nice to the analyzer back. Cannot be dereferenced.
What
Option.
is cell.left? Yeah, it's just like that. Yeah, there's no box.
So, the block.
Okay.
How do we lose our?
If let sun begin block.
I see. We just lost our.
Okay. So in theory, should we try it?
I mean, in theory, of course, it's going to work.
It's gonna work.
This is titanium swan engineering.
Titanium swan engineering. It will work. Okay. Here's our dream test case.
CDR.
Cutter. No, do car. Do car.
Car.
Yeah, and do A and B. Do the exact test case we were going to do, right? So quote. You need quote. Yeah. But single quote. Yeah. Left paren. No. I can't type in this part of the terminal.
I'm on it. Why can't you?
There we go.
Yeah.
Yeah. We did it.
Is that what you wanted to do?
No, it's wrong. It's close though.
Let's say A.
We need to eval right.
Whoa. And cutter return nil.
Yeah.
Okay.
We need to eval right. That was the whole point of doing quotes. Yeah, there we go. Yeah, now try it.
I mean, this thing doesn't have hot reload. Why is it unimplemented? Is that even still a thing?
What? Why is it unimplemented?
If left is a value,
yeah.
Why is left not a value?
Or can you set a breakpoint on return where it returns unimplemented?
Got this, I believe. Okay. Debugger, run and debug. Whoa, what did it do? Run and debug. Come on. Sure. Oh, do we not have a debugger?
I mean, we debugged the test case before. Okay. We're so close to victory.
We are. We're going to snatch defeat from the jaws of LLDB here. Oh my goodness, how many shells? Permission to stop. Did I pick the wrong debugger?
I would just go into the main where it said, like, on your test case when you could click in the source code to debug it. I would try to do the same thing, but for main.
Okay, that seems reasonable. I suspect that my launch JSON creation here.
Yeah, just nuke that.
Close, so I'm going to delete this. I must have picked the wrong.
The wrong debugger integration.
Yeah, the wrong debugger integration. Why it made me choose, I don't know. But if I click this one. It was so close.
So close. We saw it almost work. So we got that going for it. We can try to think it through a little bit.
Yeah,
all right.
I mean, I can like restart the window or something. But that'll lose you and like, oh.
So.
I don't even know why we have 5 terminals here. Okay. All right. What happens if we click this?
Okay, we're just gonna do this. Well, shoot.
No.
Hey, yeah, this is We're not quite ready for recursive evaluation yet. So I can tell you what we should do, and we don't have time in the episode to do it, but we should take this list. In this, you remember when we had this we created the cells from a vector, and that gave us this tree.
Yeah.
We need to do the inverse operation. We need to take that tree and turn it back into a vector. Then we need to go evaluate everything in the vector and then pass that as the arguments. So what's happening is the thing we're evaluating here is a cell. But we need to evaluate actually the thing inside the cell, if that makes sense.
What I'm hearing is that this is an easy bake oven / next week topic.
Yeah, we're quite close, but not like 5 minutes close. It's like half an hour close.
Okay. Well, we lied.
But we saw CAR and CDR run. It just did slightly the wrong thing.
Did we actually see them execute?
Yeah, if you go execute it right now, if you execute it right now, it will work and just be slightly wrong.
Okay. Anyways, this was fun as always. And we will see you next week.
See you next week. Thanks for coming, everyone.